Next, we're going to be solving exponential equations. The main thing to focus on when we're solving these equations is having the exact same base. So the first thing we're going to do is rewrite these equations to where they have the same base. We're always going to go smaller. We're never going to get these bases bigger. So whatever the bigger number is, we're definitely going to take that down to a smaller number. Sometimes we have to change both bases, sometimes it's just one. Then, once they have the same base, we can set their exponents equal to each other and solve for the variable that's in that exponent. So I have 4 to the x minus 1 equals 2 to the x plus 5. I need to change the bases here to where the exact same. I know I can change a 4 to be 2 squared. 4 is the same thing as 2 squared. And since that has a base of 2, and the right side of my equation also has a base of 2, that's what I want to use. So this 4 is going to become a 2 squared, and then I still have this x minus 1 that was already the exponent. That is equal to the right side. That hasn't changed. We're keeping that base of 2. Now that they have the same base, we can set their exponents equal to each other. So then I have 2 times x minus 1 equal to x plus 5. And then we can solve this like a regular equation, just solving for x. The first thing I'm going to do is distribute the 2. So now we have 2x minus 2 equal to x plus 5. Then I'm going to subtract x from both sides. So now on the left side we just have x. And I'm going to add 2 to both sides. So on the right side we have 7. There is our value of x here. 2 to the 3x equals 4 to the x plus 2. This one's very similar to number 1, where we can change both of those bases to be 2's. Remember, I'm making the bigger one into a smaller base. So the left side's not going to change. We still have 2 to the 3x. Then on the right side, I'm changing that 4 to a 2 squared. So 2 squared, keeping our original exponent, x plus 2. And now we can just focus on setting those exponents equal to each other. So 3x equals 2. I'm going to go ahead and distribute 2x plus 4. Then when we subtract 2x from both sides, we get x equal to 4. Notice here I went ahead and distributed that 2 into the parentheses, and that's where I got the 2x plus 4. Number 3, we have 1 over 81 equals 9 to the 2x minus 4. Although this is a fraction, this 81 by itself is bigger than 9, so I know I want to bring that 81 to some 9 to a power. So I know 1 over 81 is the same thing as 81 to the negative 1, but I can also change the 81 to a 9 squared. So now this is going to become 9 to the negative 2 equal to 9 to the 2x minus 4. And I can set my exponents equal to each other. So negative 2 equals 2x minus 4. Add 4 to both sides. 2 equals 2x. So then my value of x is 1. In number 4, I'm going to change both bases to be integers, to be whole numbers. You could change the 8 to a 1/2, but I'm going to make both of them just 2. So this 1/2 becomes 2 to the negative 1. We still have the x minus 3. Then the 8, that's 2 cubed, so I have 2 to the 3, keeping that 2x. Now they both have a base of 2. Again, you could have made them both a base of 1/2 if you wanted to, but I like having the integers. So now I can focus on the exponents. I'm going to go ahead and distribute that negative 1. So we have negative x plus 3 equals, and 3 times 2x is 6x. Adding x to both sides, we have 3 equal to 7x. And then dividing by 7, our x value here is 3 over 7, and we have solved that equation.